Hey guys, we start our last unit today, which is on probability. We'll only spend probably the rest of this week on probability, and then next week we're just gonna wrap up the class with some review, and that's it. Can you believe it? So weird. Okay, so we do have some words to terminology to get through here. Today we're just starting out with the basic words and problems of probability. And you'll see my first point here is that you will see this again if you take prob and stats your junior or senior year with me or Mr. Bale. And we will remind you that you learned this in Algebra 1, but hopefully you will remember despite the fact that most people don't. But anyways, here we go. So probability is the likelihood of an event occurring. And we denote it like this. This doesn't mean probability or P times A. This doesn't mean a function notation like f of x. This means you read this as the probability of event A. Why do we use A? It's just kind of what we use. If you want to use x, you can, and you'd read that as probability of event x. Things to note: to find the probability of event A, you take the number of favorable outcomes and divide by the number of possible outcomes. We'll get more into this. Remember that probability, most people say, I saw this in 8th grade. Probability can only be between 0 and 1. It can be 0, and if a probability of an event is 0, that means it will not occur. If the probability of an event is 1, that means it is certain to occur. So probability can take on any value between 0 and 1, including 0 and 1. You can represent probability as decimals, fractions, and also percents. So if we're talking about percents, this obviously would be 0% and 100%. But those are acceptable ways to write probabilities. Some other words you need to know: an outcome is the result of a single trial. And I'll give you an example of this in a second. The sample space is all the possible outcomes from whatever you're doing. And an event is any outcome or group of outcomes. That might be confusing and overwhelming, all these at once. So just wait a second here for our example. So if we have a die, the book calls it number cube. So on your worksheet tonight, if you see anything referred to number cube, they're talking about a die. I don't think they're allowed to say that because of gambling purposes, but that's just my guess. Okay, so if we're looking at rolling an even number on a die, that's considered your event. Remember, it's any outcome or group of outcomes. And this is just an example that I made up. The sample space, remember, is all the possible outcomes. And we use that squiggle bracket notation to list all the possible outcomes. So when you roll a die, wow, I have one here because my son left it. I didn't even mean that to happen. You have the sides 1 through 6. So my sample space is the value 1, 2, 3, 4, 5, or 6. The outcome, remember it says, is the result of a single trial. So when I roll that die, what can I get? I could get a 5, I could get a 1, 2, 3, 4, 5. But what did we want to get in this case? We wanted an even number. So that's why I only have 2, 4, and 6 listed here, because these are the favorable outcomes from the sample space. So that's just a little example to show you what those words mean. Okay, so there are 2 types of probabilities. Just to go through the wording, the first one's called theoretical probability, which is the probability of an event in theory. So in theory, when I roll a die, okay, what's the probability that I roll an even number? Well, let's go back up here to our definition. Number of possible outcomes. So on a die, there's 6 sides. So that means there's 6 outcomes. So that's my denominator. And my numerator is the number of favorable outcomes. That means, what do you want to happen? We want an even number. Well, we just talked about up here, there are 3 even numbers on the die. So 3 divided by 6 is 1/2. So it's saying, in theory, the probability of rolling an even number is 50%. If I stood there and rolled a die over and over and over again, the likelihood of it getting closer to a half would be the longer you actually stood there and rolled the die. But that's a conversation for when you take probability. It's called the law of large numbers. The more you do an experiment, the closer that theoretical probability, that experimental probability gets to the theoretical probability. I will try to stop bogging you down with other things. All right, let's look at number 2. So a bowl contains 12 slips of paper, each with a different name of a month. Find the probability that a slip selected at random from the bowl has a name of the month that starts with J. So you are assuming, or we're going to assume, that all the slips are the same size and they're not folded in different ways. Everything is equally likely. So we want to know what's the probability that it starts with a J. So my denominator is the number of possible outcomes. So again, this is theoretical probability. There are 12 months. And so how many begin with a J? Well, we've got January. I could sing you the song I learned in preschool. I should embarrass myself. I should have my son sing it, but he's sleeping. January, February, March, and April, May, June, July, August, and September, October, November, and December. Those are the months of the year. Going stir crazy here. All right, so you got January, February, March, April, May. You've got June. You've got July, August, September, October, November, December. Okay, I think we only got 3. Seem to always screw that up. All right, so 3, that's your favorable outcomes because it says we want it to start with a J. So 3 out of 12, you always want to simplify those fractions. That's 1/4 or 25%. So there is number 2. Going to jump over here. I kind of changed my notes after I wrote them out. So the second type of probability, remember the first type is called theoretical. The second type is experimental. The way that you find it isn't really any different. It's if you are doing an experiment or not. So experimental probability is the probability based on data from repeated trials. So if we were in class, we would do this thing called the dice lab where you would actually roll a die 100 times and I'd have you record what you get every time. People are like, oh, that's so annoying. I'm like, really? What's more annoying, doing that or listening to me? Probably listening to me. But we're not in class and I'm not going to make you do that. So experimental probability, it's the same thing. Probability of an event, this thing would focus, is the number of times an event occurs divided by the number of times the experiment is done. So let's look at what I'm talking about here. So number 3, we have a book manufacturer, doing great, inspected 1,000 books at random, their books in their factory. They found no defects in 992 books. What is the probability that a randomly selected book has no defects? So probability, no defects. So why is this technically called experimental probability? Well, because we're looking at some book manufacturer and they're actually examining books and figuring out how many defects there are. So looking at our equation, number of times the experiment is done, they looked at 1,000 books. So that's your denominator. In your numerator, number of times an event occurs, how many books had no defects? They said 992. So that's your numerator. Just to be a little bit different, you can simplify this fraction if you'd like, but just to be different, to show you how you could write it as a decimal, if you put that in your calculator or just use your brain a little bit, remember that would be 0.992. To talk about percents for a second, remember to go from decimal to percent, you move the decimal twice to the right, so that's 99.2%. So either one of those answers would be good. If you wanted to leave it as a fraction, you would have to simplify that. So that means there's a 99.2% chance that a randomly selected book has no defects. It's probably pretty good. Okay, so again, it's still probability. It's just called experimental because someone's actually doing an experiment. So number 4, our answer isn't actually going to be probability, but it's related to it. So let's look at it. So the same manufacturer, I can't say that word clearly, manufacturer as in number 3, so the same book people, they have 8,976 books in their warehouse. If the probability of book has no defect, like we just found in number 3, is 99.2%, predict how many books have no defect. So it didn't say find the probability, it just said predict how many books have no defect. So What's the rate of not having a defect? We said 99.2%, which is 0.992. So just for people who like to follow kind of like a formula, I took the probability of no defect. And think about, what are you going to multiply that by? Any idea? No one's answering me clearly. The number of books. So I'm going to take 0.992 and multiply that by how many books they had, which is 8,976. If you're like, no, wait, it's 1,000. Well, in number 3, they said they looked at 1,000 books. We didn't know how many total books they had. They just looked at 1,000 books. And in number 4, they're telling us that they have 8,976 books in their possession. So out of those 8,976 books, we know there's a rate of 0.992 of not being defective. So using your calculator and multiplying that, you're going to get 8,904.192. So stop and think. Can you have 0.192 of a book? We've talked about this before. So no. So you're going to say approximately 8,904 books. Again, this answer is not a probability answer. You're using probability to answer the question, just to be clear here. Okay, jumping back to the next topic. So we did the 2 probabilities. They're called theoretical and experimental. The next topic that we need to talk about that has to do with probability is something called the complement of an event. And that consists of all the outcomes not in the event. So let me show you what I mean by that, if this thing would focus. So if the example was possible outcomes for rolling a die, we've talked about how you can get 1, 2, 3, 4, 5, or 6. And I didn't put it in the squiggles because I didn't ask for sample space. But the possible outcomes, we can get the numbers 1 through 6. The outcomes for rolling, say we said an even number, that's something we talked about at the beginning of this video. We said those are the numbers 2, 4, and 6. So if I asked you what's the complement of rolling an even number, so basically I'm asking for everything else that's not an even number, which in this case is all the odd numbers, which is 1, 3, and 5, which are, right, if I crossed out 2, 4, and 6 because those were getting an even number, complement basically means everything left over. So what's left over? 1, 3, and 5. 1, 3, 5. Equation, I guess there's equations that go along with this. For a complement, you take the probability of that event, in this case it was getting an even number, and if you add the probability of not that event, which in this case was getting an odd number, you will get 1. In other words, if you solve that equation for a probability of not the event that you want, it's 1 minus the probability of the event if you subtracted that over. If that is confusing, 1 minute and we will come to the rescue here, hopefully. All right, so number 5, let's talk about how you could use the complement to solve this one. So on a TV show, you, the contestant, must choose one of 5 envelopes. One envelope has the grand prize. So I want to know, find the probability of not choosing the grand prize. You're like, Mrs. Swanson, I can figure this out without complements, and that's totally fine, but I just want to show you how complements can be used. So we want to know what's the probability of not choosing the grand prize. So that means I can take 1 minus the probability of choosing the grand prize. The grand prize. Again, this is one way to do it, and this is, I don't really think this is the easiest way, but just to, again, talk about complements. So 1 minus, so the grand prize, so my denominator is 5, because there are 5 envelopes, and the grand prize, only one of those envelopes has the grand prize. So it's 1 minus 1/5. I mean, for those of you who need to see it, 1 is 5 over 5 minus 1 over 5. That's 4/5. Many of you would say, hey, if there's 5 envelopes and one only has the grand prize, 4 out of 5, of course, is not going to give you the grand prize. But again, just to demonstrate complements there. Okay, and the last, I'm just checking my work here. The last topic that we have to talk about is something called odds, which is very similar to probability, but it is expressed in a different way. So odds describe the likelihood of an event by comparing favorable and unfavorable outcomes. We do not write odds as a fraction. I'm going to show you how you write it right now. If we ask for the odds in favor of an event, this is how we write it right here. This is a number. We'll do an example like this in a second. Number of favorable outcomes. Then you write a colon, which means 2. Number of unfavorable outcomes, meaning what don't you want? How many are there that you do not want? The odds against an event, the number that comes first is the number of unfavorable outcomes, meaning the number that you don't want. 2, again with the colon, number of favorable outcomes. So let's look at an example. So here I have a, homemade spinner with the numbers 1 through 8 on it. They're all supposed to be the same size and equally likely. So number 6, find the odds in favor. So that means we want to get, if there was a spinner on this, the spinner landing on a number greater than or equal to 6. So greater than or equal to 6, remember that means, so in this case, I'm looking at 6, 7, and 8, just to write that down for people. So it says odds in favor of landing on a number greater than or equal to 6. So I want to get a number greater than or equal to 6. So how many numbers are greater than or equal to 6? 1, 2, 3. So I write that first, 3. So then I do the colon, 3, 2. The second number is basically everything that's left, everything that I don't want. So now I'm going to look at all the numbers just less than 6. How many are there? 1, 2, 3, 4, 5. So I read that as 3, 2, 5. As a hint, these two numbers here should add up to the total number of outcomes that you could have. So I had 8 pieces to the pie. 3 plus 5 gives me 8. Let's look at another one. Number 7, find the odds against. So this time, I don't want to get the spinner landing on a number less than 3. So against, landing on a number less than 3. So less than 3, remember that's not including 3. So that's just 2 and 1. Okay, so it's kind of confusing, but it's saying you do not want to get a 2 or a 1. Let you think about that for a second. The odds against the spinner landing on a number less than 3. You do not want to get a 2 or a 1. So that means you do want to get a number greater than or equal to 3. Just to think about that. Okay, so if we go back to the notes, right? Odds against an event, number of unfavorable outcomes. Okay, so how many unfavorable outcomes are there? Remember, it's the odds against the spinner landing on a number less than 3. I don't know why I'm pausing. It's like as no one clearly is going to answer. I just want you to think about it. Do you actually think while I'm talking? I don't know if you do. So against the spinner landing on a number less than 3, meaning we do not want to get a 2 or a 1. And so in this case, an unfavorable outcome is going to be getting something bigger than that. So we obviously know we have 2 odds against. So that's going to be 2, 2. How many are left? 1, 2, 3, 4, 5, 6. 2 to 6. So if we simplify that, 2 to 6, well, what goes into 2 and 6? You can simplify that. I can divide each of these by 2. So that gives me 1 to 3. You might be like, well, 1 plus 3 is an 8. Well, when you check before you simplify it, 2 plus 6 does give you 8. All right, and the last one here, number 8, find the odds in favor of landing on an even number. So that means you want to land on an even number. So if we look here, how many are even numbers? 1, 2, 3, 4. Okay, how many are not an even number? 1, 2, 3, 4. So remember, you read that as 4 to 4, and 4 plus 4 gives you 8, so that's kind of like a check. But if you simplified that, 4 to 4, that would give you as 1 to 1. So this kind of wraps up. I'm just checking one thing because I can't pause this. And of course I'm odds against tomorrow. That's not what I'm looking for. I'll pause this and make a second video. But so anyways, here is our probability unit.